Hello viewers, welcome to video number 112 of the channel MALACHEMPHILIC, and this video number 112 is the 52 episode of Chemical Thermodynamics, and topic of this episode is partial molar property. So let's start. Partial molar property. See, a partial molar property is a thermodynamic quantity that describes how the total property of a mixture or solution changes when a small amount of specific component is added, while keeping other variables like temperature, pressure, and the amount of other components are constant. Essentially, it represents the contribution of each individual component to the overall property of the mixture. So, let's try to understand this description. See, if you take a closed system, okay, this is a closed system, then change of the state of the system is considered to be due to the change in the temperature, pressure, but the total mass remains constant. This is for closed system. So here what we observe that is the change of the state. This is your closed system. So, change of state is considered due to change in temperature, pressure, but no change in the total mass, because it is a closed system. But when you are taking a open system, then there may be change. Say we are taking the open system of a mixture, that is the mixture of two or more components. Then there can be a change in the number of moles of different components. So this is our open system. So here, so we have taken the open system of two or more component. So it is a mixture, right? Components. Then there can be, and for this system, there can be a change in the number of moles of various components. So this is possible in open system because it just exchange not only the energy, also the mass. So there can be change in the number of moles of various components. So under this condition, in that case, for open system, therefore for open system, any extensive property like, say, internal energy, enthalpy, Helmholtz free energy function, entropy, Gibbs free energy function is not only the function of temperature and pressure, means any extensive property not only changes with the change of temperature and pressure, but also the function of number of moles of various components. Okay, that means any extensive property not only changes with the change of temperature and pressure, but also changes with the change in the number of moles of different components. And for the open system, number of moles of components may change, right? Because it exchanges the matter also with the surroundings, right? Then what can I write? Suppose if X is an extensive property of the system. Extensive property. Say X may be entropy, enthalpy, internal energy, anything. So X will be a function of temperature, pressure and number of moles of different components. Component 1, component 2, like that up to say component J. Okay. Then the quantity, what is the quantity? Dole X by, or before that I'll write this one. So X is an extensive property which is the function of these things. Then what we can write? Dx is equal to dole X by dole T at constant pressure and the number of moles of all the components when they are constant, n1, n2 nj dt plus dole X dole P at constant temperature and number of moles of different components nj. Okay, so X is an extensive property of a mixture where a number of components are present and those number of components have number of moles n1, n2 like that up to nj dp plus dole X dole n1 temperature, pressure and other components are constant n2, n3, nj dn1 plus dole X by dole ni temperature, pressure say nj, okay, n1 nj and j not is equal to I because it is varying with ith component, then dni. Okay, we can write like this. Then the quantity, what is the quantity? This dole X by dole ni at constant temperature, pressure and constant composition of other component J not is equal to I. This quantity is known as partial molar property here I have taken in terms of ith component. So partial molar property of ith component. Then how can I define this one, partial molar property? So partial molar property, or here partial molar property of ith component, is the change in that property with respect to the, with or per mole of the change of the component, here it is ith component, per mole of the change in the component, okay, when a infinitesimal small amount of that component is added to the system under constant temperature, pressure and the composition of other component. So change in the property with per mole of the component, here it is I, so per mole of the ith component, okay, when a small amount or infinitesimal amount of that component is added to the system, keeping temperature, pressure and composition of the other component constant. So this one we can write it as this del x by del Ni at constant temperature, pressure N1 dot dot Nj, J not is equal to I. So here how can I define? It is the change of the property, okay, change of the property with per mole change of, with per mole of the component, here it is, here ith component, with per mole of component when infinitesimal, that means very small amount, infinitesimal of the component is added to the system, keeping temperature, pressure and composition of other component constant. Okay. So change of this property with per mole of this component, here it is ith component, when infinitesimal of this component, infinitesimal amount, here I write infinitesimal amount of the component is added to the system, keeping temperature, pressure and other composition of the other components are constant. So this is the partial molar property. So now we can understand this description. Partial molar property is a thermodynamic quantity that describes how the total property of the mixture, this property of this mixture or solution, mixture means number of components will be there and solution also number of components will be there. Mixture or solution changes when small amount of a specific component, here it is ith component, is added while keeping the other variables like temperature, pressure and the amount of other components are constant. Clear? And essentially, so it represents the contribution of each individual component to the overall property of the mixture. So, this partial molar property represents the contribution of each component to the overall this property of the system. Okay, and this partial molar property of this Gibbs free energy is known as the chemical potential. In next video, I will discuss that. Hope you have understood. Thank you.